All right, well, hello, 8th graders. This video lecture is meant to do some debriefing based on that starter activity you did for this lesson. It's going to introduce us to this idea of the conservation of energy. But to begin that, I'm going to talk about bank accounts. So I'm going to make an analogy here with bank accounts and how it can actually help us think through the conservation of energy when we have these different energy accounts being filled. So my bank account is composed of 3 different accounts. Okay, these aren't actual numbers, so don't be like, oh, Mr. Welch has $3,800 in his bank account. But my bank account has 3 different accounts within it. And those accounts sum to a total amount. Now, I can go into my online banking and I can move money between these accounts. So for example, let's say that I want to take $500 from my checking account and move it to my savings account. So what is that going to look like? Well, I'm going to have $500 then left in my checking. My joint checking stays the same, but my savings goes up to $2,500. But now notice that if I sum all of these values here, I end up with the same total amount here. So I can do stuff within my account internally. I can move money to those different accounts, but I'm always going to end up with the same amount that I started with. Now, where this gets interesting is that this number can change if I get paid. I have money then coming in, right? So money is going to get added to this total amount. The other thing that can happen is I have to pay a bill. Money then leaves my account. So I can do stuff internally within my bank account to change how that money actually looks within it. The total amount then would never change. But things can happen externally where I could get paid or I could make payments. This total amount can then change. So I want you to keep this idea in mind when we start talking about how energy accounts are filled based on certain scenarios that we look at. And once we move further in this unit, we're going to see that the amount of energy that we have within a system can actually change based on external things going on. Where in this case, with the bank account, it was me getting paid or it was me paying those bills. All right, so with that bank account analogy in mind, the conservation of energy, this is where the real science starts kicking in here. The conservation of energy tells us that energy cannot be created or destroyed. So in our universe, or let's look at a little bit smaller, in our world, there is a set amount of energy, and that amount of energy cannot change. However, it can change the account that it is in, just like in the bank account analogy. Okay? And it can also move into or out of systems that we define. So the system in the bank account analogy was my bank account. And you could see that if I get paid or I make payments, the amount of energy that I have in that account can change. Okay? So, really simple example to help us see this. I have a ball that is at rest, so the velocity is 0. That ball is dropped. And we're looking at that ball being dropped and looking at it right before it hits the ground. So what we have here, we have 3 different snapshots. We have right before it's dropped, halfway to the ground, and right before it hits the ground. Before it is dropped, you should understand that because this ball is at some height above the ground, it has all gravitational potential energy. So I'm going to use one of those pie charts that you should have seen in your lesson starter here. And I'm going to say that this pie chart is completely filled with gravitational potential energy. Now, as this thing begins to fall, what's happening? Some of this gravitational potential energy is being transferred into the kinetic energy account. Because that ball starts moving, some of this gravitational potential energy that we started with is transferred to the kinetic energy account. So halfway down, my pie chart is going to be roughly half and half, where I'm seeing that some of that gravitational potential has been transferred to my kinetic account. Now, the last snapshot here, right before it hits the ground, like that millisecond before it hits the ground, we no longer have a height here, so there is no gravitational potential energy. All of that gravitational potential that we started with has now been transferred to the kinetic energy account. Now, there was a question that I asked you in that lesson starter. I asked you what the size of this pie chart represents. I hope that you can see here that this pie chart, it stayed the same size. The size of the pie chart represents the amount of energy we have in this system. And in this case, our system is very simply just the ball and the ground, or the ball and the earth, however you want to say it. Okay? So now, moving to this next scenario we have here. It's the same scenario, but take a look at what's going on here. This ball is starting at a greater height than it did in this first scenario. So what does that mean? That means that I have more energy in this system. So my pie chart must be bigger. And it's bigger at all three snapshots. Okay? So, once again, initially, all I have is gravitational potential. Halfway down, some of that gravitational potential has now been transferred to the kinetic energy account. And then finally, right before it hits the ground, all of that gravitational potential has been transferred to the kinetic energy account. All right, so the last slide, the big takeaways there are understanding how we can connect that bank account analogy to conservation of energy. You saw how that gravitational potential that ball started with was then transferred to the kinetic account as that ball started to fall towards the ground. Now, those pie charts, that is a model that we can use to document energy at various snapshots. The other model that we can use is what I call an LOL diagram. Okay? What we do with the LOL diagram is we take initial and final snapshots of a particular scenario, and we document which accounts are being filled at those initial and final positions. The O is where we document which objects are in our system. And the O is going to have even more significance as we move throughout this unit here. Okay, so let's look at scenario 1 here. We're going to say that before the ball is dropped is our initial snapshot. And then right before it hits the ground is our final snapshot. So initially, which energy account is being filled? The correct answer there is our gravitational potential. Okay? Now, our final snapshot, again, right before it hits the ground, well, if you look at your pie charts, we saw that all of that gravitational potential was transferred to the kinetic account. Now, notice that these bars that I have here, initially and finally, are basically the same height. That's showing that I have the same amount of energy initially and finally in this system. Now, I did forget to write out what my system is. So again, for this simple scenario, the objects within our system are just the ball and the ground. I'm going to put the earth. Okay, ball and earth, that's it. So, scenario 1, pretty simple. Now let's look at scenario 2. All right, so for scenario 2, let's see if I can erase these here. There we go. All right, so scenario 2. We have the ball again. Ball is at rest initially, so there's our initial snapshot. Now our final snapshot, notice the difference here. Our final snapshot is halfway down. So initially, very similar to the first, all gravitational potential energy. But now, our final snapshot again is halfway down. So if you take a look at those pie charts, again, that should indicate to you that we don't have all KE here anymore. We have some amount of KE and PE. So, our final snapshot is going to look something like this. Now notice that if I were to add up these two bars, they are going to sum to equal this bar right here. The whole point with the LOL diagram is we want to make sure that our initial and our final snapshots equal one another. That's showing that the amount of energy that we have in that system is the same, but the way that those accounts are being filled is just a little bit different initially and finally. Again, related to the bank account analogy. You can move things around within those individual accounts, but the total amount in that bank account stays the same. All right, so use this information to help you out with the practice activity for this lesson. If you have any questions, please let me know. Take care.